To find the derivative of f of x equals e to the cosecant squared x, we're going to need to utilize the derivative of the exponential function as well as the chain rule. In fact, we're going to need to utilize a chain rule within a chain rule, because really what we have here is e to the cosecant x, which is squared. Okay, see, this cosecant squared x is just suppressed notation for cosecant of x squared. And so we're going to have a chain rule within a chain rule here, but we'll take it one step at a time. So we're ready to take the derivative, and the function itself that we're looking at is basically an e to the u, an e to something ugly. So the derivative of e to the u would be itself, so e to the cosecant squared x, but then we've got to take the derivative of the exponent there, because it's not just x, it's a function of x. So I'm going to write this in just the ddx step, ddx of cosecant x squared. Okay. And so to finish off our derivative, we're going to have to take the derivative of cosecant of x squared, and that itself is a chain rule too. And so let's keep going here. We've got e to the cosecant squared x. And then to take this derivative, we have it of the form something ugly raised to a power 2. So this is like a power rule, but we have to pull out the derivative of the inside. So to complete that derivative, we bring down the power 2, and then we would have the base there, cosecant of x, and then we just drop the power by 1, right? Because this is a power rule. So the new exponent is just 1, so it's really just cosecant of x. And to finish off the chain rule, we have to take the derivative there of the inside. So we're taking the derivative then of cosecant of x. And that derivative is one of these memorized derivatives you have for this section. All right, so to finish the derivative, we've got that one final derivative to take. So we'll keep writing. We've got e to the cosecant squared x. And then we've got times 2 cosecant of x. And then the derivative of cosecant of x is negative cosecant of x cotangent of x. And so at this point, we've gotten rid of all of our ddx's, we've completed our derivative, but we could certainly make this look a little bit easier. All of these terms are multiplied together, and so in particular, I think I would group this 2 and this negative sign here together and just pull that constant out front. So I would have then a negative 2 for those two. If we're looking here across the board, we've got a cosecant of x. We've got another copy of cosecant of x. So itself would be cosecant squared x with that suppressed notation. And then we've got a cotangent of x, so we could put that next. Oops. Cotangent of x. And then I usually tack on the exponential at the end, just because it makes it clearer what's in the exponent when we're writing. So e to the cosecant squared x to finish off the derivative.